Institute of Aeronautical Engineering, Electrical and Electronics Engineering. Tech Talk. Name N. Venkat Sai. Roll number 2395180226. Branch and year. Electrical and Electronics Engineering, second year. Subject: Control Systems. Topic: Water level controller using a microcontroller. Water level controller using a microcontroller. Explore how microcontrollers revolutionize water level management with automation for homes and industries. Introduction: The need for automated water management. Water wastage issues. Manual control leads to overflow and water loss. Labor intensive monitoring. Constant supervision in inefficient and costly. Automated solution benefits. Ensure precise control saves water and reduces human effect. System architecture. Overview of the components. Microcontroller. Central control unit processing sensor data. Sensors detect water level precisely within the tank. Relay module switches water pump on off based on controller signals. Water tank reservoir where water levels are monitored and controlled. Microcontroller selections. Choosing the right brain. Consider processing power. Faster units enhance real-time responsiveness. Input pin availability. Must support required sensors and actuators. Power consumption. Essential for energy efficient automation. Community support. Widely used platforms. Essay developments. Sensor integration. Detecting water level accuracy. Ultrasonic sensors. Non-contact and precise distance measurements. Float switches. Mechanical and cost-effective monitoring. Pressure sensors. Measure water pressure to infer level. Capacitive sensors. Detect level via water dielectric properties. Software design. The control algorithm in action. Reads sensor data. Compare with threshold. Active pump if low. Stop pump if full. Repeat cycle continuously. Hardware implementations. Building the prototype. Assemble components. Microcontroller, sensors, relay, power supply. Connect wiring. Ensure correct pin connections and ensure secure soldering. Upload control code. Program microcontroller with control algorithm. Power and test. Initial functionality check the troubleshooting. Testing and calibration. Ensuring reliable performance. Sensor accuracy verification. Compare sensor output with actual water level. Pump operating check. Confirm pump engages and stops preciously. System stability testing. Assesses performance over extended periods. Calibration adjustment. Tune threshold and timing for best result. Testing and calibration. Ensuring reliable performances. Sensor accuracy verification. Compare sensor output with actual water levels. Pump operating check. Confirm pump engages and stops preciously. System stability testing. Access performance over extended periods. Calibration adjustments turn thresholds and timing for best results. Result and analysis metric. The need for automated water wastage issue. Manual control leads to overflow and water loss. Labor intensive monitoring. Constant supervision is ineffective and costly. Automated solution benefits. Ensure precious control. Saves water and reduce human effects. System architecture overview of the components. Microcontroller, central control units processing sensor data. Sensors detect water level preciously within the tank. Relay module switches water pump on off based on controller signals. Water tank reservoirs where water levels and monitoring and controlled. Microcontroller selection choosing the right brand. Consider processing power. Faster units enhance real-time responsiveness. Input pin availability must support required sensors and actuators. Power consumption essential for energy efficient automations. Community support widely used platforms development. Sensor integration detecting water level accuracy, ultrasonic sensor, non-contact and precious distance measurement, float switches, mechanical and cost-effective monitoring, pressure sensor, measure water pressure to infer level, capacitive sensor, detect level water dielectric properties. Sensor integration detective water level accurately, ultrasonic sensors, non-contact and precious distance measurements, float switches, mechanical and cost-effective monitoring, pressure sensors, measure water pressure to infer level, capacitive sensors, detect levels by water's dielectric properties. Soft design. The control algorithm in action. Reads sensor data. Compare with threshold. Activate pumping low. Stop pumping full. Repeat cycle continuously. Hardware implementation building the prototype. Assemble components. Microcontroller, sensors, relay for supply. Connect wiring. Ensure correct pin connections and secure solderings. Upload control code. Program microcontroller with control algorithm. Power and test. Initial functionality check and troubleshooting. Testing and calibration. Ensuring reliable performances. Sensor accuracy verification. Compare sensor output with actual water levels. Pump operating check. Confirm pump engages and stops preciously. System stability testing. Assess performance over extended periods. Calibration adjustments. Tune threshold and timing for best result. Future enhancements. Scalability and additional features. IoT integration. Remote monitoring and control via code platforms. Mobile app. Use friendly interface for alerts and manual override. Data analytics. Track usages patterns to optimize water consumptions. Solar power compatibility. Energy efficient operating for off-grid locations. Thank you.